Chemical kinetics. This chapter is basically deals with the study of the rate of the reaction. The rate of the reaction means the speed with which the reaction proceeds. So it's a branch of chemistry which deals with the study of the rate of the reaction, factors affecting it, and the mechanism of the reaction. So the basic idea of studying the rate or the speed with which a reaction proceeds, or how much time a reaction takes to get completed or to reach to the equilibrium, gives us a very valuable information regarding the reaction. Now, this information can be used to either further find out that what all are the factors on which its rate or the speed depends. And if once we are knowing those factors on which the rate or the speed of the reaction which depends, we will be able to manipulate its speed or rate, which can make us which can help us to speed up those reactions which are useful to us, which are actually very slow, or which can slow down those reactions which are actually useless but are very fast. So this is a very important study, which is a very important part of the physical chemistry. Now every reaction has to go through this process of the chemical kinetics, because ultimately what all are the external factors, what all are the internal factors, which guides or which helps or which affects the rate or the speed with which the reaction proceeds are studied in this. This study also helps us to find out what all are the temperature, pressure and other conditions which makes the reaction more feasible, more spontaneous in certain conditions. There is one more important thing. While studying all those things, or all these related concepts or the factors regarding a reaction, we goes into the mechanism of the reaction, which is the stepwise how the reaction takes place. So all these helps us to understand the reactions in a much better way. Now, but the first thing is to understand what exactly is the rate of the reaction. So the first topic to be done in this chapter is the rate of reaction. See, the rate of reaction is the speed with which a reaction proceeds, or the time taken by a reaction to get completed or to reach to equilibrium. So it can be defined as the change in the concentration of reactant or product per unit time, or change in the concentration of any of the reactant or product for the time interval delta t. So if, let's take an example that A moles of A combines with B moles of B to form C moles of C and D moles of D, the rate of reaction is change in concentration of reactant or product upon time interval. A reaction proceeds can be actually explained to you by taking a simple example, like the reaction which suppose we are having, in which A moles of A combines with B moles of B to form D moles of D. Let's take initially A1 is the concentration of the reactant A, B1 is the concentration of the reactant B, and C and D formed are 0 and 0 because initially there were no products. Now at time t, let the concentration of the reactant A is A2, the concentration of reactant B is B2, let it be this one be C and this one be D. So what we find is change in concentration is how much? It will be A2 minus A1, which is written as delta of A. So you need to know why I'm putting a sign negative here. Because this A2 concentration of the reactants at time t is lesser than the initial concentration, because it is the reactants which are getting consumed. So their concentration is always less than the initial concentration. That is why when we are subtracting A2 and A1, we will get the answer negative. So it's negative of delta of A, and this A is kept in square brackets, and we know anything which is kept in square brackets is always a concentration. Similarly, change in the concentration of B will be B2 minus B1, which will be negative of delta of B. It will be C minus 0, which will be called plus delta of C, and it will be D minus 0, which will be equal to plus of delta of D. So this is how we can represent the change in the concentrations of either A or B or C or D. But again, now we know the time interval in which these change in the concentration has taken place is T minus 0, which is called, let it be, delta T. So what now we can write is, we can write as this as rate of reaction will be equal to minus dA by dt. This is change in the concentration for the time interval dt, or it can be delta of B by delta T. Both are negative because we know the concentration of reactant is decreasing. It will be plus delta C of by delta T, or it can be plus delta D by delta T. So all these are the different forms of the rate of the same reaction, and we need to understand that these are the four different ways we can find out the rate of the reaction. Remember, we can find out the rate of the reaction by considering any of the reactants. If we are considering reactant A, then the rate of the reaction which we have got for the conversion of the A moles of A combining with B moles of B to form C moles of C and D moles of D, that will be called the rate of decomposition of A. So remember, all these four expressions are giving us the rate of the reaction, but these rates are different. What they are different? This rate is giving us what? The rate of decomposition of A. This is giving us rate of decomposition of B, because both of these reactants are getting decomposed. Then the C, rate of formation of C. This expression is giving us rate of formation of D. So remember, we can find out the rate of the reaction with respect to any of the reactants or products. But remember, those rates will be with respect to those particular reactants or product only, and therefore they will not be the rates which will be equal to for all or equal to all the reactants and the products. It will be exactly actually what? Those expressions will be specific to that particular reactant or product, like this one. And these different rates of the same reaction which are obtained from with respect to different reactants or products cannot be same. Why they cannot be same? The four rates which we can got from for the same reaction, they cannot be same because we know the reason is that the coefficients of these reactants and the products are different. It's not that we know that A moles of A is reacting, but it's not the A moles of B which is also reacting. It is B moles of B. Since their coefficients reacting are different or formed are different, these four rates determined cannot be equal to each other. They cannot be same. But yes, the reaction rate of this reaction can be expressed in any one of these four ways. It can be expressed in terms of either A or B or C or D. So this is how we write it. But if we want to compare their rates, we can do this. The rate of this reaction, which can be expressed in terms of any of the reactants or the product, can also be represented by an expression in which we can compare the rates of these reactions. this reaction which is determined with respect to different reactants and the products. And this can be written as the rate of reaction will be equal to minus delta A by delta T minus delta B by delta T plus delta C by delta T plus delta D by delta T. Now, these four as such are not equal to each other. We can compare and make them equal to each other by what? Why they are not equal? Because their coefficients are not same. But they can be made equal to each other by dividing them with their coefficients like this. Because once we divide them by their coefficients, they all turn out to be per mole out of 1 mole. When 1 mole of this A reacts with 1 mole of the B, it's like this. So then we can compare their rate, and then their rate when determined with respect to either A or B or C or D will be equal to each other. So this is how we can write down the rates which are actually obtained for the same reaction from the different reactants or product. They can be compared with each other like this. And we can write, if we know the rate of a reaction with respect to any one of the reactants, yes, we can find out the rate of the reaction or rate of the decomposition of the other reactant or rate of the formation of the products with respect to that reactant like this by using these simple relationships which are obtained from the balanced stoichiometric equation. So let us take an example to study how we can write down the same thing or represent the same thing. Let us take an example of the Haber's process, in which what we find is it is the nitrogen which reacts with 3 moles of hydrogen to form 2 moles of ammonia. Now the rate of this reaction, remember the rate of this reaction can be determined with respect to either nitrogen or hydrogen or ammonia, formation of ammonia. But remember, all those 3 rates will be different from each other. Their values will be different, though they are for the same reaction, because the coefficients of the three substances which are involved are not same. But they can be compared like this. How? By minus of 1 by, since its coefficient is 1, so there is no point in writing down this. It is minus of concentration of nitrogen upon delta T. It will be minus of 1 by 3 of delta of hydrogen by delta T, and it will be plus of 1 by 2 of delta of ammonia by delta T. So this is how we can compare the rates of the different reactants and the products like this, and this is a way of writing down the rates of the reaction. So for any given reaction, we can easily find out what will be its rate.